Welcome back to Balvikan Bharti with your mentor Avila Sarkar. We already discussing about the transpose of matrix. There we have seen one property of transpose. When we do the repeated twice transpose of any matrix, we will get back the matrix again. The next property of this is this is the second property you can say on the transpose of matrix is that if I multiply two matrix and do the transpose of them, will have the same result if I do the transpose of individual matrix in the order I have written and then multiply, then the result will be same. So A into B2 matrix, if I do the transpose of this, will get the same result if I do the transpose of the later one then in the order, because that has to, because this is a definite property or we can say for the matrix, if we change the order the result will be definitely not definite, could be changed, I can say. So this is depends on the kind of matrix, so that will come later. But for now, if I say that A into A and B2 matrix, if I do product then take the transpose of that, that will give the same result if I do the transpose of the later one and get the transpose of the earlier one, and then we multiply in the order that is written here, we will get the same matrix. Let's say this I am getting as C, this is also getting the C. But this proving needs some knowledge of you can say the multiplication that is not being taught right now. So this I am holding here and I will prove it when you will learn the multiplication of any matrix. So till now park it somewhere. So now the next the variety of the matrix is called the scalar. So this is your ninth scalar. Okay, this is not exactly a matrix, you can say is a involvement of matrix. What we can say that if in algebra what we do, if I multiply any number, let's say with another number, let's say 2, I will get the twice of that number, isn't it? Or if I do multiply an alphabet with any constant, this is will get the twice of that alphabet. So that means this will not change the property of this, rather it will come as, we can say, this is twice of the identity. This if I say in some identity, this will give the twice of that identity, it will add to that as a prefix. So this similar kind, if it is happening with the matrix, let's say if I multiply k, which is any number, with any matrix, let's say I am taking for example A, B, C, E, F, G, H, I, J kind of matrix, and if I want to multiply this, and if it is any number, just a numerical, then the effect of this I will see like this. Every element of this will be multiplied with the same scalar, and this will be equal to this. I am putting an equal sign, so that means the value of this, if I calculate the matrix and then after if I multiply with this k value, which is a constant, any numerical value can be, then the result will match if I calculate this as a matrix and get the value. So both the values will be same, and this k is defined as scalar here. Okay, so scalar means a constant, if that multiplied with the matrix will increase each element of the matrix by the same you can say multiplication factor. This is only a multiplication factor for that matrix, and each element will be affected in a same with the same multiplication factor. Okay, so that means if it is 2, so that means each element will transfer to, instead of writing this, I can write this will be the same. Understood? So this is scalar. Now specifically we can say in case the k value is -1, for any situation, if it is such that the k value is -1, then the matrix, original matrix, if it is if I say of 2 order CD, then that k into matrix A, and k if it is -1, let's say k is -1 into A, this will turn into this. Okay, so this is called negative of the matrix, not negative matrix, negative of the matrix. So that means if I take minus common, so that minus will come as a sign, because 1 definitely have no specific increment in the value, so that may come as a sign only, and it will be similar to the matrix, and we can say this is, so this is called the negative of the matrix, not the negative matrix. This is a correct presentation, or you can say the representation of a matrix, when this will call negative of a matrix. So that means we will call negative of a matrix when scalar is equal to -1. So this is a specific case, that's why I am writing here. It may or may not be useful in your numerics. So just for example, I am just giving it. This scalar is basically useful where we will work with the vectors. Okay, so you know, if any vector is multiplied with the scalar, it won't change the vector, because vector is consist of magnitude and direction. So if the magnitude changes, only the vector will be enlarged. So let's say this is a vector, if I multiply with, let's say 2, so vector will be enlarged by 2 of the vector, but the direction of the vector won't change. So that means that vector will be enlarged or will become bigger. So with the scalar, effect of effect of scalar on the vector is only the magnitude increases. So that the same thing is there, because matrix also can be useful to solve vectorial problem mostly, because when we work with the two vectors, it's very easy to put the parallelogram law or the triangular law. That triangular law or parallelogram law is very useful when we will talk with about two vectors. But if it is a multiple or n numbers of vector, n could be of any natural number. If so many vectors we have to work with, it is not possible to work with two vectors at a time and go on adding this. So this will be very big process then. As I said in the earlier videos, solving two linear equation with a means replacement method is very easy. But if in case the number of equations, linear equation is huge, so you will get 10 numbers of equation as the 10 variables are coming. So putting them in a combination and solving it, you will get your whole day to solve it. So it is not possible. So their matrix is very useful. So as in vectors also, where there is number of vectors is acting in a body, and in equilibrium body, if number of vectors, let's say number of forces is acting to put a body in equilibrium, there could be a n numbers of forces. Now to solve in one instance, you need to have this help of this matrix. So there, this kind of scalar is useful. Okay, so the next comes your this is relative called the number 10, and this is probably the last kind, if I'm not wrong. This is called the inverse matrix. So this is not actually the inverse in algebra. What we defined, that if say 2, if I take the inverse of that, this is half, that means 2 minus 1. But the representatives of similar kind, let's say having matrix A, the inverse is represented at A inverse 1. That's the representation is same as in algebra, but the meaning is not such, because 1 by matrix A, this is not the case. I will get the inverse of that. It needs some different method to calculate the inverse. So although the representation is similar to the algebra, the inverse is not being calculated a matrix also. Now let me take it in sequence of this kind of matrix, but it is not exactly, this is a part of matrix, but it's also a matrix itself. So this is called your minor. So minor definitely a kind of matrix, you can say it's a matrix, but it's a part of a matrix. So let me take some example. Let's say a matrix is given by A in the order of 3 cross 3, I'm saying A, B, C, E, F, G, H, I, J. This is a 3 cross 3 matrix. As you know, 3 cross 3 means 3 rows and 3 columns. Here the elements are A, B, C, E, F, G, H, I, J. Now, how to get the minor of this? So, to find the minor of this, every element has its own minor. So, that means every element, if I say about this elements, so what would be the minor of this? Now, minor of, when we will get the minor, this matrix what we are talking about must be of square matrix. This is my declaration. When we will talk about the minor of any matrix, the matrix must be of square matrix. That's why the order must be the rows equal to the column. So this is my first declaration. The first condition, you can say, condition of first is that the matrix must be square matrix. Okay, this is the first condition of that. Now, if A is represented by this, and now we are saying that if each elements have one minor matrix. Okay, so and that is order of n minus 1. As I said, the n minus 1 means as I am taking this example of 3 cross 3, that could go with any order, let's say n into n. Let it be very generalized. I am not writing so much of terms, that's why I have taken the specific one, but nevertheless each term, if I can write up to n terms here and n terms, and if I take n cross n, where n could be any value which is a natural number. Okay, so any value belongs to a natural number or natural or real number, you can say. Real number could be a fraction, but here fraction is not acceptable. These are all integers. Okay, remember that. Then any natural number. So if n cross n of order, any matrix is there, and if I get the minor of that, so each element have their own minor. What I am saying, let me write it. Each element have their own minor of order n minus 1 cross n minus 1, because as it is a square matrix I have accepted, if the order of the original matrix is n cross n, then the minor has to be of n minus 1 cross n minus n order. So this is my first take from this definition of minor. Now what is minor? So as I said, each elements have their own minor. So how do you find that? So this element must cross through some row and some column. If I drag a line and the pivot of that two lines will target the elements for which I will calculate the minor. So what I am saying, I will cross two lines, one horizontal, one vertical line through the element which I am targeting to find minor for it. So that means if A is a target for me, I am crossing horizontal line and vertical line, and it is being pivoted on the object on the element, and for that element my minor would be the remaining which is not passed through that line. Understood? So now it is very easy to understand. If I take a specific order 3 cross 3, so if I take the 3 cross 3 and if I cut down, so the remaining is, if I say this is also a matrix, then yes, because this is containing in the order of 2 row 2 column, and this is order of 2 cross 2. So let's now see, this is n minus n, so this is 3 minus 1 cross 3 minus 1 order. Okay, so and this minor is specific to this, because none of the element which is not coming under this matrix is passed through both the lines, because this is only passed through both the lines. B is cut by one horizontal, this is cut by this also one vertical, this one. So only this element is cut by two lines, one is horizontal, one is vertical, and the remaining which is not cut by the lines is minor for the element which is cut by both the lines. This is concept. Now if I extend it for this, now I will cut it with vertical line, this is already there in the horizontal line, so now this is my pivot. So in this case, what are the elements which is not passed by the lines, because I am just considering on the vertical lines, this one and horizontal this. So this is my pivot point. So these two elements and these two elements is not passed through the lines. Now for this element, my minor will be, if I write separately, my minor will be separately E, G, H, J, and this is order again 2 cross 2, whole is 3 cross 3, this. So each element, this is specific because this minor cannot go with any other. You can see no two lines being cut with this arrangement. Understood? So whenever I will want to find the minor, so I have to see two lines not compulsory you have to draw the lines. You can get a picture of that lines when you will, if we just put your hand on the element, you can understand this and this is obsolete, so you cannot see all this, so the remaining was this one. So if we consider all this part, you definitely can understand what are the things which is not coming under the line. Okay, that you can automatically pretend in your mind, and you can accordingly get the thing. Okay, so and for this, these are the things, and for this, these are the 4 number elements, this will not come. So this, now by this way you can get all the minor for all the elements. Now thing is that this, if I take say about only one particular element, the minor of this could be Now we can understand this is also a matrix. So minor can be considered as a kind of matrix, but it is again a part of a matrix. So that's why I am not trying to say it a matrix, but at the end this is also a matrix. So any bigger things, now if it is a 4 cross 4, now your minor size will be 3 cross 3, one step down. So then further you have to bring it back to 2 cross 3. So then whatever the elements there each having, then again it's minor. So minor can be sorted down or reduced down to a minimum of 2 cross 2. 2 cross 2 is the minimum order of that minor. Understood? Because below that the matrix will not exist. It will come down to a number only. So 2 cross 2 is the minimum size of the minor that is possible to drop down from a bigger size of bigger order of matrix. Understood? So this is the minor. And now a few concepts that need to be discussed. One of this kind, if I say a matrix having some order 3 cross 3 and there are elements, okay, so these elements have a specific sign which it carries. Because why I am saying, if the elements is being broken down to a linear expression, that will follow with some predetermined sign, and the sign is calculated according to this formula. That means position minus 1 whole power of I plus j, where I is number row number and j is column number. That column number. These two So if I want to get the sign of this, which this element carries along with that always, but this will not be represented here. While we'll put the value with the element, if I say A, B, C, I will not write the sign here itself. But when we expand it, I will take the sign along with the elements. Okay, that I will explain later. But when we represent, I will represent with the elements only. But when we will put it in expression, I will expand it, I will take the sign. That is so my statement is that during presenting matrix, we will not present with their inherent signs. Okay, so that means these elements have their inherent signs only represent during representation. If it is being taken from any equation, I will take the sign of the suffix, what is the sign it is carrying in the equation, but these elements having their own signs. So how that will vary, but during representation I will not put the signs along the elements. You remember these two things. The signs that will be represented here, let's say I am writing 1, minus 2, 3. That doesn't mean that the sign is of the sign which is inherent to the position of the element. When I expand it, then again the inherent sign will come into picture. But this signs, it is being taken if say x minus 2y plus 3z is equal to something x. So this is the sign it will come here along with this where equation is there, but these elements having their own sign, and the sign varies with this formula -1 whole to the power I plus j. So that means this position, if I only represent the sign, it will follow a pattern, and that can be easily memorized. This is -1 whole to the power I plus j if I say. So for this is I and j, this is the first column on first row. So this is definitely be I is equal to 1 and rho is equal to 1. The second one is I is 1, rho always 1. This is 1, 2, 3. This is 1, 2, 3. So here your row number is 1. Okay, column number is what? This is column second plus 2. This is row number is 1, column number is 3. Sorry, here 3. This is -1 whole to the power row number 2, column number 1. Row number 2, column number 2, row number 2, column number 3. This is row number 3, column number 1, row number 2, column number row number 3, column number 2, and row number 3, column number 3. Now if I calculate this, what we will find? For 3 cross 3 matrix I am showing, and this will be applicable for any order of matrix in the same order. So but it becomes -1 whole to the power 2. So that means -1 whole square. That means plus, this is -1 odd. -1 to the power odd means always negative. Negative. -1 to the power even is positive. So you can see the pattern plus minus plus is starting from plus. With the any order, you move with the same order, plus minus it will go. And this way you see -1 whole to the power odd minus this way -1 plus. So this way also. Now if you remember the extreme left top is plus, both way if you down, it will alternatively change the sign. So this is very easy to remember. So anybody can do it by seeing, if you remember the first position of the sign. Understood? This will be helpful when I will expand any matrix. So just for remembrance, you just remember this is starting from plus, and alternatively the sign will change. That's all. So starting with plus positive sign, and any direction means horizontal and vertical, not the cross direction. Any direction is this. Any direction means horizontal and vertical only. Direction sign alternately changes. Understood? So here I will stop here because things are going bit informative. So I should not go very fast, and every time I will start, I will repeat the things again, so that it will be a hit to your you can say the memory. That may has to be sharpened every time. So that's why I will start little bit back and then I will go forth. So this way that overlap will come in your study, so that you can easily can say revise the things that have been taught in earlier classes. Okay, so thank you for now.